All right, welcome back to another episode of web development. Let's take a look. We are quickly getting started on the seventh module, and we've been introducing the JavaScript as the programming language of the web. Right? We've been learning how to use JavaScript to create dynamic content, right, based on using data structures and user input forms, right? And before that, we were just using HTML and CSS to create static content, right? You know, um, Other than perhaps creating responsive web pages, right, that could adapt to screen sizes and also could relay out the different columns and either hide or show different things for different screen devices, right? Other than that, it was pretty static. And so we've introduced in the last couple of modules that we can make our applications more data driven, right? And we've introduced being able to capture data structures like arrays and objects that could uh, represent the user interface, right? And then build React.js applications that can read these data files and then convert them into an equivalent user interface, right? Basically, living up to the role of React.js, which is to build a function that can convert or transform data into an equivalent user interface. So today we're going to keep going, discussing using JavaScript, TypeScript, React.js to be able to manipulate these data structures, right? Be able to maintain user state, right? As meaning that as users interact with these data structures, right? That they click and they drag and they can manipulate these data structures. They can add new objects, remove objects, right? Create new objects. They can edit existing objects, and so these data structures change over time, right? And that's what we call state. State in an application, we mean the collection of all the variables and data structures that can change over time. They can evolve over time as users interact with the application. So we need to determine how is it that the user interface also needs to change over time, right? To reflect these changes, right? If you remove something, right, by clicking on a delete button, then needs to be removed also from the user interface, right? So any manipulation to the data structures, any changes to the state of the application need to be reflected in the user interface. Okay. This doesn't mean that we don't have the capability yet, right, to make these changes permanent, right? So there's for instance, because we're running inside of a browser, right, we can't make any of these changes, maybe save them back to a file, or saving into a database. We don't have that capability because we are running inside of a browser, and we don't have those options. So all these changes that we are going to introduce that we can manipulate these state user state is only going to be temporary, right? It'll be transient. We'll see the changes in the user interface. We'll learn how to manipulate these data structures, but we'll need to wait until the next module when we start discussing how to make these changes permanent. For that, we'll need to introduce additional technologies such as servers, REST APIs, and eventually databases. Okay, so yeah, but this is a good introduction to that capability. All right. And also, I think I have these backwards. The state, we're going to be talking about state Redux here. Next week, we'll have the first exam. So yeah, so we are quickly coming to the middle, the halfway point to the course, right? And soon we'll have the exam later in the next module. Okay. All right. Okay. So if you do go to module 7 or week 7, you'll find references to a couple of slides. I'm going to go through the labs that are associated to the fourth assignment. We'll introduce the fourth assignment, as well as quiz 5 is also available this week. So make sure not to forget about taking the quiz. You do have a couple of days to take it, right, at your own pace, but please don't forget to take that. All right. Okay. So we're going to introduce the fourth assignment that it talks about how to handle the events, right? As users interact with an application, they click, they drag, they type at their keyboards, right? And usually because they're interacting with some form that they're filling out, right? And so we need to know how to handle all those events, all those clicks, all those typing in the keyboard, right? How do we convert that into state changes, and how does that state change then reflect into a new user interface? So let's talk about creating how to handle these events. So first, let's create a lab 4 component where we can play around with some of these exercises. So let's see. So we had created an application, right, that we've been using throughout the semester, where we have had several assignments, right, that we've been learning different skill sets. So let's create one for the fourth assignment, right, which is going to have, like all my assignments, we have the first half is labs or exercises for us to practice some skills, and then we'll learn how to apply those skills, right, to augment our ongoing implementation of the Canvas application. All right. So let's create a lab 4 screen, right, where we can play with the skills of manipulating a state in an application and how that reflects into the user interface. So let's create a lab 4 directory, and then in there an index.tsx. So this is going to be our lab 4 screen, right? So this will be export file a little bit too big. Function lab 4, and then we'll just return something like that. Lab 4. There we go. And then we'll add it to our navigation, our table of contents. So we'll have lab 4 over here. This will be lab 4. This will be lab 4, 4, and 4. There we go. And then now lab 4, we don't really have anything, right? So let's add that to our navigation, and I believe that would be in app.tsx, right? In our labs, we can have a route for lab 4. Let's do that. So lab 4, and I'll put a star just in case the lab 4 wants to have its own navigation. Oops, let's import that. There we go. Okay, there's lab 4. Okay. Maybe let's make this a little smaller. There we go. Okay. All right, so we have a placeholder where we can put in all our exercises. Let's start looking at some of these exercises. So first learn the basics of handling users being able to click, right, on different things on the screen. So all the elements, all the DOM elements in HTML, right, can have an attribute called onClick that allows you to bind a function that will be invoked, if you click on that element. Now over here is being applied to the button, right? But in reality, it can be applied to any element. So you can make, a header, you can make it clickable, right? A div can be clickable, anything can be clickable. But more commonly, right, we have, we apply it to things that are recognizable as being able to be clicked, right, such as a button. And this is the case here. So let's create a click event. component where we can play around with this idea. So let's see here in lab 4, let's create a click events component, and let's copy the content in there, and then we discuss on this side. So here we have just a header, right? We have 3 buttons, right? And they're all clickable. Here's a click. Let's add this to lab 4 so that we can see it rendered on the screen. So we'll say, click event. There we go. There it is. So there they are. So 3 buttons, and they're, let's make that a little bigger maybe. And if you click on this one, it alerts hello world. If you click on this one, also it alerts some other message, your life is good. And then this one, I think, calls both of them, hello world, and then calls the other one, life is great. So let's take a look at the implementation. So these are just regular buttons, right? And the only new thing here is that we have used the onClick attribute, and then assigned it a function to be invoked, okay? And same thing for this one, right? And then this one, right? So, but the difference here is that the ways that we are calling it, and we have to be careful, right? So we have here 2 functions. One is called hello, and the other one is life is, and then we're passing here a string as an argument, okay? And so I did want to point out that if a function doesn't take any arguments, like this one, this hello, has no parameter list, then you can use this more terse or more compact syntax, right, where you just provide a reference to the function. So be careful not to use the syntax that is common in regular JavaScript. In regular JavaScript, you would use syntax like this. You would have a quotes, right, and then you would have the function and then the parentheses like that, right? This is an old, right, legacy, down to earth, bare bones JavaScript. That is the case, okay? But that syntax is not supported here in React.js. Instead, we use this other syntax where we can provide just a reference, right, to the function, right? You have to be careful not to add the parentheses like that. So you notice that it highlights, telling you that that's an error. This would cause an infinite loop, right, where the when the button renders, it would immediately invoke the function, and when you invoke the function, right, it would cause the component to re-render, which would re-render the button, which would call the function again, entering an infinite loop, right? So instead, if you don't provide the parentheses, this is good. It means that it will only be invoked when you actually click the button. Make sense? Another way to avoid, right, making these calls, right, to forget to put the parentheses here, is that you can alternatively just have this other syntax, right, where what you do is that you wrap the function, you wrap it inside of another function like that, okay? So hello world 2, say, okay? So there's 2 of these, and they behave the same exact way, right? So this is hello world, right, and this is hello world also, right? It calls the same exact function. Now, but because it takes no arguments, then you are allowed to use this more compact syntax, okay? And if you don't want to have to remember when you can use this syntax or when you have to wrap it, then you can just stick to this single syntax where you always wrap your function call, right, inside of another function call like this, right? We call this syntax a lambda function, right, that has no name. We are declaring a function. We are implementing a function here that has no name. See that? And what it's doing, it's the delegating or deferring the invocation of that function to a later time, right? When it's clicked. Okay. We also call this syntax a closure, right? And what it means is that a closure can take a snapshot, right, of what the state was when this function was declared, so that it'll remember, right, that when this function was declared, it will remember that if you had certain other variables, right, or well, obviously constants, it will remember what those values were at the time of the function declaration, which is very important we'll see in a minute how is that relevant, right? But in here, it's not relevant, right? It's just that, we are using the closure syntax, right? That we are wrapping a function instead of another function, which has the side effect of deferring the invocation until the onClick event occurs, right? Now, if you are passing an argument, like over here, we're passing a string to the function life is because it's expecting a string, then you absolutely need to use this syntax, right, where you wrap it inside of a function, right? Don't do things like where you have the function like that, right, and you don't wrap it, and you pass arguments like that. Again, you will enter in an infinite loop, right, of just calling yourself over and over, causing this to re-render and call itself again. So yeah, so notice that it gives you a warning here not to do that. Okay. So yeah, so you either always use this syntax where you wrap the functions inside a closure, right? Or right, if you do remember that if you don't pass any arguments, then you can use this more compact syntax. Make sense? So yeah, so these implementations are invoking a function that is declared up here, and whereas this other implementation, it's illustrating the fact that a function, right, can have a closure, right? This closure function, this lambda function, can have its own body, right? And within here, you can do all sorts of computations, right? You can put all sorts of code in here, right? That you can also invoke other functions. Like here, we're calling the hello function and the life is great function, right? So which happens when you click on this, right? Hello world, and it clicks it and it runs, right? So yeah, you can embed your code. The more common thing is to declare a separate function, right, and then implement the logic in that separate function. But nothing stops you from declaring and implementing it here. If it's something trivial, right, then yeah, then they keep it inside inline here, right? If it's a function that definitely is not meant to be used anywhere else, then sure, implement it right there in inline with the on click. Now, if it's a function that is a very important function that has already been declared, or something that is going to be used often by all sorts of different places, then a better implementation is that you implement it and then you pass it as a reference. Okay. All right. All right. So yeah, this is handling buttons. All right. So this other example, right? It wants to make explicit, the fact that you have to be careful when you are passing arguments, right? So So here's an example that is illustrating the fact that be careful, right? That you have a function here that adds two numbers and just alerts the value of adding those two numbers. And this is just pointing out the fact that careful, don't do this, right? That if you are going to pass arguments, remember to use this syntax, right? That to put it inside of a closure and pass it the arguments. Don't do this because you'll end up being in a infinite loop, right? So let's import that example. So there it is. So if I click on it, alerts that 2 + 3 is 5. Okay. Very simple. Everybody good? Okay. All right. So we haven't yet worked on any state changes up to this point. We're just learning how is it that we can cause, how can we handle users handling events, right? So we'll take a look at that in a minute. So passing data when handling events. Okay. All right. So how about also we want to introduce the fact that not only can you pass values to a component, you can also pass it functions, right? So let me show you. So for instance, here, right, here's a component that is taking as argument, right? This is taking as argument a function, right? The we've implemented components that take as arguments, numbers or strings or even objects, right? Like in the to-do list example that we saw earlier. In this case, it's expecting you to pass it a function, right? And then within the component, you can treat that function like you would treat any other function. Over here, for instance, we're using it to bind it into an on-click event handler so that when you click on this button, it would call the function that you are providing, that the parent is passing it as an argument. So let me illustrate that. So let's create the component that is expecting a function in the parameter list. So somebody's passing it a function, right? Notice that we're still using the destructor syntax. So it's going to be passed from the parent in an attribute, right? When it uses the passing function tag, right? It's going to have the function attribute. It's going to pass it presumably a function that we can invoke. And we need to declare it, right? In the parameter list, because this is TypeScript. We have to declare the type of this thing. And the type is a type function, right? That returns a void. And here, what we're doing is that we are binding that function that you are passing to us to this button, right? And so that when you click on the button, right, it will invoke that function that you gave it. Okay. And so here's an example on how we would use it, right? So, for instance, in the we would have a function declared in a parent component like the lab4 screen. We would have maybe a function, and then we would pass that function as an attribute. See that? Right? And so that when you click on, so this renders a button that when you click on this button, it will call this function saying hello, which will alert and display this this message, right? So let's add that to our lab4, right? The function here that we want to pass as an attribute, right? So let's add this component. There it is, and let's import it over here. All right, so there it is, right? So when we click on it, right, notice there it is. So it calls this function hello, right? So this is a mechanism by which child components. So this is the parent component, lab4. So lab4 contains all these child elements, right? And so the parent passing a function down to a child component, right, is a mechanism by which the child can talk back to the parent. Not that children should talk back to their parents, but in this case, it's how they communicate, right? They can communicate back to the parent and call the function, maybe even pass some data, right, from down the child, right? It can pass data back up to the parent, and then the parent can then maybe update some state variables up here, right? But it's a very common mechanism by which child components, right, can communicate with their parent components, right, passing functions down to them as attributes. Okay. Also, let's talk a lot about the event object. So the event object, right, whenever we are clicking and dragging and typing, right, these event handlers, these on-click event handlers, these functions that are being invoked, right, they are, right, whenever you have an on-click, the function here, when you click on it, right, the event handler is passed an event object, right? Over here, we're ignoring it. So this is the function that handles the click, down in that button declared in the passing function. But notice that it's not receiving anything. So it's ignoring anything that is passing it. So, but let's ignore it. Let's not ignore it. Let's take a look at it, at what it is. What is it that, what is it that we get, right? So here's the event object. Let's copy that. There it is. All right, so here's we have a button, right, that we are going to click, and when we click it, notice that it's using the closure syntax, right? We have here our function, right, handle click, and when you click on it, it's going to call that function. But notice what happens here. We have an e here, right, that we didn't have earlier, right? So this parameter e, right? We were ignoring it in all our other examples, but in this case, we're not ignoring it. this function is this object, this event object is always passed. And what we're doing is that we are passing it along to our function, right? So that we can play around with it and see what's in there, okay? And what we're going to do is that we're going to take that E, right? And we're going to populate a local variable events, right? Using a new technique that we haven't covered just yet. All right, we're going to cover this in a minute. But I did want to talk about the event before we talk about the use state. Unfortunately, it was the only way that I could show you the event was using this technique that we haven't covered just yet. I just want you to see the content of that event object. So what we're doing is that we're sending the event, we're sending it with the value of E, after having massaged a little bit, a few things, right? We have removed a few things from the event. We have massaged the target a little bit, right? But then I want you to show you what that object looks like. Notice that we are JSON stringifying the event object, right? I want you to show you what it looks like, right? All right, so let's bring it into our lab for the event object component. So this is the event object component we just wrote. It's right there, right? So by default, it's null. Right, notice the null. So the event is null. So that's why this is rendering as null. There it is, right? But when I click it, right, it's going to pass the event to our handler. It's going to remove a few things, right? And then it's going to display. The reason I'm removing it is because one of the things that the event contains is a reference to the button itself. The button that created the event has a reference to it. So if I try to render it, right, it's going to get into an infinite loop, right? Because it's going to say, oh, so you want to render the button that generated the event, which you want to render because it generated the event. So it gets into its infinite loop. So I converted it into just plain old HTML, right? So it doesn't have the target in the event is a reference to the object that originated the event. In this case, it's going to be this button here. And I'm trying to render it here again. So it's going to get into an infinite loop. So that's why I'm removing it. So let me click on it, and there it is. So this is the object that the browser generates, right? And it passes this to us. So this E, right? I'm massaging a little bit, but then I'm displaying it over here. I'm converting into a string, right? So there's a lot of stuff in here. For instance, one of the things that in there are the XY positions of the mouse, right? When did it happen? At what timestamp did it happen? Right? Whether you had the shift key or the control key, right? Pressed on the keyboard. There's quite a few things, right? And now one of the more important things that we're going to be caring about is the target, right? So target is a reference, as I was mentioning, right? It's a reference to the object or the DOM elements that generate the event. In this case, it's the button. So notice that here it's the button, right? It's the primary button. It's this button right there, this one, right? Display event object, that one, right? So the target always references the DOM element that generated the event. In particular, it's important when we use the input fields, like if you're typing at an input field or selecting from a drop down or filling out a text area or something like that. We're going to want a reference to it because that target actually has the current value of the input field, the text area, the drop down, right? And so we're going to be able to read that value from there. So that's why I wanted to point it out. This is mostly the only part of the event object that we care about, the target. Most everything else is irrelevant to us, unless you want to do some more fancier things, such as drawing on the screen, right? Things like that. But in most cases, that's all we are going to care about. All right. So I just wanted to show you what's in there. All right, so let's talk about component state, and what I mean by that is, within a screen or within a component, right, you can maintain, the state, a local state, which is going to be a collection of variables inside of the component or inside of the screen, and typically they will only exist within the context of that screen or that component. Right? So for instance, if you have variables that you declare inside of your component here, those would all be local variables, right? Just like here, handle click, you have a local variable e, right? That's local over here. And usually that those variables, right, only exist within the context of the function, right? So that's why I'm calling it component state, right? So state means that you might declare variables here that might change over time, maybe a counter or something, right? And as you click and drag and whatnot, the value might change as you interact with it, but it's local to the component, right? And usually it's not available outside of the component, right? I can't, other people from outside, my parent, for instance, might not have access to my local variables, right? Now, I might have, I might, pass it as an attribute down to my children, so they have access because I pass them as attributes, and they might want to communicate with me, if anything changes with that variable by calling me, by calling back to me with a function that I pass it. But usually the variables that we're talking about are contained within a screen or component. They're not meant to be used elsewhere outside of the component. That's why we refer to as component state, right? So let's talk about that. How do we manage it? It's a little bit different if you want to maintain, share this state outside of the component, either with the children or your parents or application wide, right? If you want to share it globally. So let's take a look at that. This is the most narrow scope at which you want to maintain state. So let's take a look at that. So let's look at a simple example, right? Here's a little counter, right? We're going to click on two buttons up and down, and the counter would go up and down, right? So let's create a counter. Right, so in here, component counter. Okay. All right, so here's a variable, right, that has declared count to be 7. And here we are printing the value of count. So let's let me bring this into lab 4. So this is counter, counter. There we go. So there it is down here. We have up and down. And I want to show you what the console shows, right? Because it's somewhat unexpected what it's going to do, right? Maybe perhaps a little bit unintuitive. And so take a look at the counter here. See that? Look at the counter is 7, right? And so if I refresh, okay, notice that it renders the 7, right? And it tells you that on line 5 is doing that. So line 5 right here, right, in counter is displaying the 7, okay? And then let's look at the implementation here. We have a counter, we have 2 buttons. Here's one of the buttons says up and the other button says down, right? And this one is saying, hey, when you click on this button, what's going to happen is that the count is going to go up. See that it says count plus plus, right? And then I'm going to render count. Whereas if you click on down, right, count is going to go down, right? And then I'm going to display the new count, right? So I want you to take a look at what the console does here as I click on these 2 buttons, right? Notice if I say up, right? Notice that it rendered an 8, right? So if I keep saying 8, 8, 8, right? Notice that it's changing. See that? It's going up every time. And if I click on down, notice that it goes down. So it's 9, 9, 8, 7, 6, 5. But even though the console is displaying the correct value of count, which is giving us confidence that indeed the value of count is changing, okay? Well, the value in the user interface is not changing. See that? This is not changing. The user interface is not updating the latest value of count, okay? So that's what I wanted to point out. right? And the reason is that React.js is lazy, right? And what I mean by lazy is I don't mean that it's not designed correctly or that it takes shortcuts or things like that. What I mean is that it's efficient in that if it doesn't need to render stuff on the screen, then it won't render, right? It avoids rendering anything on the screen unnecessarily, right? And so what it'll do is that it will do the minimum work, right, to render something on the screen, because it's very expensive, right, to render anything on the screen, and especially it's very expensive when to manipulate this DOM. It's extremely expensive to manipulate this data structure, right? So what it tries to do is to try to optimize the time that it needs to go out and modify this data structure, right? So it avoids unnecessary writes to the DOM, right? So as far as it's concerned, right? Count was 7, it rendered it over here, and then it's done, right? Now the fact that we are changing the value of count, okay, it is irrelevant to the components, right, that the change actually happened, right? So we need to somehow let it know that, hey, you should not ignore the value of this variable. The changes of this variable should not be ignored and should indeed cause a re-rendering of the screen, right? Now, to accomplish this, we need some additional syntax, right? We need to explicitly let React.js know that it is worthwhile, that this particular variable should change and that those changes should reflect the user interface, okay? So to do that, we are going to introduce a new function called useState, right? useState, notice that it starts with use. Okay, now all functions that start with use, that's a naming convention in React, telling us that this is a hook, right? And what it means is that it's going to allow functions, right, components that are written using functions as opposed to classes, because you can also implement components using classes. And because it's implemented as a function, there are some limitations that come with implementing things using pure functions, right? That those limitations go away if you would implement it using a class, okay? Now, to overcome those limitations, React.js introduced the notion of hooks, okay? This gives access to functionality outside of the function, right? That would otherwise be impossible to do within a function, right? So, for instance, in particular, functions are by definition stateless, right? They do not, right? They should not be able to maintain state, right? That is, the literal definition of a function, right? That it should not, if you call the function, sine, cosine, logarithmic, one of the expectations is that if you call the function, plus, and you pass it 3 and 5, well, that addition of 3 plus 5, it will always be equal to 8, right? It won't change over time. It always comes back with the same values. If you give it the same values, right, it always comes back with the same results, right? So it does not change over time. It doesn't, its behavior doesn't have side effects that remembers prior states, right, that would cause it to behave any differently every time you call it. So functions, by definition, cannot maintain state, right? So to overcome this limitation, React.js uses hooks, right, to be able to access outside behavior outside of the function that can maintain state for that function, right? And so to do that, to be able to have or to be able to keep track of the changes of count and also be able to react to it and update the user interface, introduce this useState, right? And the way we use it is as follows, right? The way we use it is as follows. We still use the 7 here, which is a initial state, right? It's the initial state of count. Count is our state variable, or we want it to be our state variable. meaning we want to change its value over time, and we want it to be reflected in the user interface, and we want to initialize it. So to initialize it, right, we are going to use useState. So useState over here is being used to initialize a variable. Now useState returns a pair of objects, right, a pair of variables, right, in the form of an array, right? So useState returns an array, right, which the first item array is the constant variable that has been initialized to the value, and also, right, it's bounded to the current value, right, of the state variable, right? So this returns an array. And so what we're going to do is that the first item of that array is the constant or variable, right? So what we're going to do is that we're going to destruct, right, from that array that is coming from useState, right, and to pick out that first item. And that, because it's an array, the binding happens by index, right, by the position that this variable or constant. Because I've been doing a let here. Okay, no, let's leave it a let for a second. So the name of this, right? I can name it whatever I want, right? Because the actual name, right, is doesn't matter because it's internal to the implementation of useState. This comes back with an array, right, of which the first item, I don't know the name. I don't really care about the name, right? I know that it's the first position, so I can destruct it and I can give it whatever name I want on this side, just like I would declare any variable. Okay. All right. So we have that. It's initialized to 7. Now, if I refresh, this won't behave any differently, right? If I show the console, we can see in the console that the behavior hasn't changed. The value has been going up, as we would expect, right? But still, right, the value in the user interface has not changed. So we're not quite done yet. Okay? We're not quite done yet. Okay. All right. So this is only the syntax for declaring the state variable, or declaring this as a state variable, and also to initialize it. The second part is the updating of the state variable. Okay. Here we are doing it by updating the state variable directly, right? Because it's a let. Okay, we can manipulate it, and indeed it is changing. We can see that it's changing. We're consoling out, right? And it's we got the value. Okay, right, it's going up 15, 16, 17 as we would expect. Okay. But what we're going to do is that we're not going to do this. We're not going to use this method of modifying our state variable. We see that it's not working. It's not doing anything, right? Instead, we're going to use a function, the second argument or the second item in the array that comes from useState, right? So useState comes back with an array with 2 items. The first item is the variable, the state variable, and the second item is a modifier, right? It's a function that's going to allow us to update the value of that state variable, okay? And again, it's the second item, so here we can call it whatever we want, as long as it's the second item in that position. Now, the naming convention is that it's going to have the same name as the state variable, and right, the keyword set, right? So it's going to be set count, right? So that is the naming convention that all these mutators are called. They start with set, right, and then followed by count, and then the whole thing camel cased, right? So this is going to allow us to modify the state variable and also tell React.js to say, hey, React.js, this variable has changed, and I want you to honor this change, right? Don't ignore it. Okay, I want you to update the user interface at your earliest convenience, okay, and to reflect the fact that this has indeed changed, right? And that notification only happens if you use the mutator instead of modifying this directly. So instead of using this implementation, what we do is that we would do, set count plus 1. There it is. See that? So notice that now if I do an up, indeed it is changing. See that? It changes to 8, right? 8, see that? Now the up works. Now if I do the down, notice that it does not change because I'm still using the older count. Notice that it is indeed changing the value, right? We're console log, we're displaying. So down is indeed changing the value, but it's not being notified. The React.js is not being notified that it should not ignore this change, right? And indeed is not updating the user interface. So instead of this implementation, right, instead we're going to use the set count to be set count minus 1. And now it does work, right? If we go down, right, now it changes to down and up goes up, right? So it works as expected. Make sense? So very quick, very easy changes, right? Instead of using just a regular identifier, we use the useState. We initialize the value. We wrap it inside of a square brackets for the destructor. We declare a mutator function, right? And then we make sure to update that value with that mutator, never updated directly. Make sense? All right. All right, so let's take a look at a couple of other data structures that can be converted into a state variable. So for instance, here we have a Boolean state variable, right? That where we can keep track of the current value of a Boolean variable, right? That is changing between true and false. So let's grab that. And what we're going to do is that we're going to, in lat 4, we're going to have the Boolean state variable. There it is. Let's close this. So there it is. So here's a state variable that when you interact with it, when you click on it, I think this one, the checkbox, right? It causes the user interface to change, right? Either show or not show this message down here, right? Let's add a couple of breaks underneath, so we have some space underneath like that. There we go. So if I click on this, notice that it hides and shows content. So let's look at the implementation. So if we go in here, we have the done state variable, which is initialized to be true, right? And then we have a mutator set done, right? And then we are using the variable done state variable, like we would use any other Boolean constant, right? So here we're using it in a ternary expression that if it's done, it renders as done. So it's instead of a paragraph, right? So if it's done, the paragraph renders done. If it's not done, if it's false, then it renders not done, right? And here I'm toggling it, done, not done, right? And indeed, the paragraph is indeed updating correctly. Here we also have the checkbox, and we see that it is a type checkbox. It's by default, the value of the checkbox is set by checked, right? Checked, and the value is done. So it's either checked if it's true or not checked if it's false, right? And then you have an on change, right? That what it does is that like on click, right, invokes a function, if you click on something. Whereas on change, again, there's several event handlers, but on change, what it does is that it checks to see if either a text variable or checkbox or a dropdown or a text area, right? What it does is that it invokes the function, right, whenever anything changes within that input field or that particular button or checkbox or radio button, right? And what it does here is that we are using the mutator to toggle the value of done, right? So set done, if done is true, then it would call it with set done false, right? And if done is false, it would call it with set done true. So it's toggling the value of done every time you click on this checkbox, okay? And then we're using it here in the done, right, to have an alert box, right? That's a little class. This is a bootstrap class that either either we are showing the div or not, right? Depending on whether done is true or false. If it's true, we show the alert box, right? If not, then we don't show the alert box, okay? There's a question in the chat. Can we do it like set count, count plus plus? I mean, yes, because, well, actually, no, count plus plus. So count plus plus would increase the count afterwards, right? So it would first call set count with the current value of count and then update it. But then it would update it. It would update it not in the state variable. Instead, it would update it in the local, right, which would not cause the re-rendering. Okay, so it might cause it to to be delayed by 1, right? So that you would expect it to be 14, but it's actually 13 because it's looking at the prior value, right? If you do plus plus count, then yes, right? You are updating, you're first incrementing the local one, right, and then causing the state variable to be updated like the local version. Yes, if you do plus plus count, then yes, but not count plus plus. All right, so let's take a look at playing around with state variables for strings. Okay. There was another question whether the value can become negative. Absolutely. Anything, it's just a regular integer value, and so anything that you can do with an integer, it would also be applicable here as well. So yeah, no limitations on whatever the data type is. What the data type behaves like any other regular data type. All right, so let's take a look at string, right? When the value or the data type is a string, we want to be able to manipulate it. For instance, when you want to type a new name or last name or whatnot, right, inside of an input field. So let's create a little component where we can play around with string state variables. And so here we have a state variable that we called first name that we are initializing to John, and then you have the mutator, right? And so here's you have an input field, right? First, we're displaying the first name as a paragraph. So let's import this into lab4. So this will be string state variable like that. There it is. So I'm displaying it John here. There it is, by John. And then we have an input field that it defaults the value to be first name. So it's showing here the current value of John over here. And then as I start typing, what's happening here is that every time I type a single character, right, this event handler is going to be invoked. And notice here we are taking a look at the value of the event object, right? Notice that in the prior examples, we are also receiving the event here, but we are ignoring it. We're not using it. Same thing with the counter. When we're clicking, right, the event is being passed through, but we are ignoring it. Here, we're not going to ignore it because, in particular, we want to capture the current value of the input field, right? So as you type, every new character is appended, right, to the current string, and the current value of whatever value we had plus this new character is being passed to us in the event handler. So it says, well, this is the current value. So if you say, John Y, right? If you type John Y, then this would be John Y, right? Now, if you don't have this on change, it would never be appended. So because we need to, what we're doing here is that we're accumulating, right, all those changes into the first name, right, with the new value of Y, then T, then F, and then Z, whatever, right? And each new character, right, is being appended, and we are collecting it into the state variable, right? And that's what we are displaying here, okay? All right, I'll let you play around with the date state variable on your own. Let's take a look at the object state variable. So we're taking a look at progressively more interesting data types, right? So we took a look at some of the primitive data types and how to work with states for those primitive data types. But what about, complex data types such as objects? So here's a simple object where that it's missing a comma, where it declares two properties, name and age, right? So let's create a component where we can play around with object state variable. So this is combining several data types, right? So instead of having just one primitive data type, we are initializing a person object, right, to have initially this name and this age, right? And then we have a mutator. Okay. So we're first going to display the current person as a stringify it, right? So let's show that what that looks like. So the object state variable will display it here. So object state variable. So there. So we have name Peter and age 24, right? And then we have these two input fields, right? The first one and second one. Each one presumably that allows us to modify individual attributes or individual properties, the name and the age, right? So this first input field, right, it's initialized with the name in the person object, right? So person.name, so it's initialized to Peter. There it is, Peter. Okay. Where the other one is initialized to age, and as you would expect, it renders as as advertised, right? Now, to modify it, we want to be able to modify the object, right? And we want to be able to modify individual parts of the object, right? The name or the age. And so to do that, the way we're going to do that is that we are going to use the mutator, right? Because we need to tell React.js that, hey, something changed. You should modify the user interface, right? And to do that, what we're going to do is that we're going to calculate a new object, a brand new object that is going to be first initialized to contain the old object. Right? So ... person, what it does is that it copies into this new object. It's going to copy over the old object. So this new object starts off with Peter and 24, right? But then we have a comma here, and notice that we're using a property that already exists in the object, right? We already have name Peter and age 24 right in here. But because we have a second one that has the same exact name as a property that I already have, basically I'm going to override the value of that name property, right, with a new value. What is that new value? Well, it's the target value, right, of whatever I am typing in that input field. So as I am typing in that input field, Piet, so changing Piet or whatever, right? It's updating only the name with a new value, right? That is from where I'm typing in that input field. And the same thing for the age. I can individually change different properties by first copying over the old one, right? And then overwriting the particular one that with a new value, from wherever I'm parsing in from the input field where I'm grabbing the value. Okay, so this is a very common technique, right, to be able to modify individual object properties, right, without having to have individual functions that deal with the name, another individual function that deals with the age, right? So just one mutator, right, and then you can then modify that particular property. Okay. All right, so continuing with our complex data type, let's take a look at arrays, right? So let's create an array component here that collects several values, several entry points, right? So let's take a look at that. Let's paste that in there. And then I believe we have a second part to this. There we go. So let's take a look at the code. So here we are initializing a variable called array, a state variable that initializes with 5 elements, 1 through 5, right? And these are integers, but they can surely be whatever you want, right? They can be strings, booleans, objects, states, or even a combination of everything, a little bit of everything, right? And then we have two functions that is going to allow us to add to the array. Another one that's going to allow us to remove from the array. Okay. So first we'll let's see how we can render this. Right. So we'll revisit this in a minute. But let's take a look at how we can edit or render this first. Right. So we have the array state variable. So in lat4, let's import that array state variable. So there it is, right? So we have the array. We have each one of the items. Let's take a look at how this is rendered. Notice that it's a UL, so it's a list, and we're iterating over the array, mapping it. So here's the item. Now the map and all the iterator functions like find, filter, they all have take as a parameter list, right? They call a function, and that function can, we've seen examples where it only takes one argument, which is the item on which we are iterating over, right? But there's also a second argument to that, okay, called the index. And so this is a counter that tells you where are you in the iteration, right? Are you in the first item, meaning 0, position 0, 0, 1, 2, 3, and so on and so forth. So index will be 0, 1, 2, 3, 4, right? As we're iterating over each item, right? Now, typically we don't use the index, but in this case, it's useful. Okay. So one of the things that as we're iterating, notice what happens here. We are iterating. We're displaying the item value. So the item is the values in the array. So it's 1, 2, 3, 4, 5. So there they are. So 1, 2, 3, 4, 5. There it is, right? But then notice that we have a button here. See that button, and the button it says delete, right? So basically, we are adding one delete button to each one of these items, right? And so let's add an extra space in there. There we go, extra space. And so, but notice that the button, right? The button has an on click, which is going to invoke the delete element. Okay. But we also have a button here at the top that says to add an element. So let's take a look at this one first. This add element. Right, so if I click on the add element, notice what happens, right? Notice that it added an item at the bottom. If I click on it, just adding some random values at the bottom of the array. So let's look at the implementation. So what it's doing, right? Add element is calling this function up here. See that? And what it's doing is that it's using the setter, the mutator, to calculate, a new array, right? And then update the old array to have these new values. And so what it's doing is that notice that it's setting it to a new array. There it is. It's an opening array here and a closing array, which is going to have at the beginning of this new array is going to have a copy of the current array. Right? So if I click on this once, right, it's going to copy over, 1, 2, 3, 4, 5. And then notice that there's a comma here. See that? So that means that after I copy those first 5, it's going to add a new item in the end. So this new array has a brand new element at the end of the array, right? That calculates a random value between 0 and 100, right? In the floor. So math random times 100. So math random calculates a number between 0 and 1, right? It's a random value. But then we're scaling it to 100, right? And then we are flooring it so that to remove any floating point values, right? So that's why these are all random. If I keep clicking on it, basically it's copying all the values again, right? And then just adding a random value at the end. Okay, so that's how add works, right? We create a brand new array, we copy over the old array, and then we right a new value at the end, right? Whatever that is. In our case, is just a random value. In your case, it might be that you're adding a brand new object, right? A brand new string, right? A brand new whatever, right? In our case, it's something trivial, which is adding a new number. Okay. What about delete? So delete here if I click on these delete, notice that it removes just those elements, right, from the array, that one element, okay, and then it just and then re-renders the new array, okay. So how does it work? So basically, delete elements, right? It's calling this delete element with the index of the item that you're clicking on. So if I click on 21, it'll call it with 0, 1, 2, 3, right? It'll call it with 3. So meaning remove the third item here. See that? So what it's doing is that we're getting the index of the item they want to remove. And so what we're doing here is that we are calculating a brand new array. So filter, if you remember, can calculate a brand new array from an old array. So here's the old array I'm filtering out. It says, well, I don't want the item whose index is whatever you pass me here, right? So I'm going to iterate over the array. Here's the index of each one of the items. So 0, 1, 2, 3, 4, right? When that index hits the index that I want to remove, then I don't want it. So what I'm saying here is that if the index is not the one that I'm removing, I want it in the resulting array. So I want all the elements in the array that are not the index that I'm trying to remove, right? So basically it's going to skip over that index, right? So this new array is going to have all the elements of the old array minus the element with the index, okay? So that's how that works. Now, one thing to point out, right, is that as I am iterating over the array, notice that this index is different, for each one of them. So somehow this delete element needs to remember that the index in the first element was 0, and the second one is 1, 2, 3, 4. And the reason it remembers that is because we are in a closure, right? Remember, I told you earlier, right, that one of the features of a closure is that it remembers what were the values, right, of parameters and variables and constants and whatnot, when the function was declared, right? And we are declaring, 1, 2, 3, 4, 5 functions, right? Each function needs to remember that the item was, or the index or whatever, item and index was 0, 1, 2, 3, 4, 1, 0, 1, 2, 3, 4. And then the items were 1, 3, 4, 96, and 66, right? So that's why when I click on it, it knows that this is, the fourth element. So it's calling delete, 4 or something, whatever. Okay. Yeah, very important. All right, so let's take a look at sharing data amongst components, right? So earlier we had mentioned that certainly we can pass, attributes from one component to the next. We've also shown you that we can pass around through the attribute. We can pass a function, right? So I want to illustrate, right, how these two, a parent component and a child component, can talk to one another through the use of these functions and change the state of values, right? To cause the child, for instance, to have the parent change its state. So first of all, let's create a child component. All right, so we have here child component, and it has this value. So okay, so this child component, right, being passed a counter value, and so someone else is responsible for the counter. We're being passed the value of counter, which I am going to render right here, right? So notice that I am not responsible for maintaining the value of counter. Someone else is maintaining the value of counter. I'm just being passed the current value here for rendering purposes, right? And then also we are being passed a mutator, right? And the mutator, here I'm using it so that when I click on increments, I'm going to call that mutator, right, and increment it by 1, or if I click on the decrement, it's going to call it set counter -1. So presumably, I'm going to tell my parent who sent me this function, I'm going to inform the parents, right, that, hey, the counter should be decreased or incremented, right? But notice that I am not responsible for doing any of that, right? I'm just invoking and letting the parent know that these events occurred, and this is what should happen. But me, myself, I'm not responsible for maintaining that. Instead, right, it's a parent component who is responsible for doing that, right? So we have a parent component here, okay, that is indeed maintaining the state of the counter, right? So the parent is maintaining the state, right? It is initializing it, but then notice that it itself, parent, right, is not doing the modifications of these. It's never invoking counter or set counter. Instead, it's passing, right, these functions down to the child component. And the child component is going to be the one responsible for, right, handling the events, right, and then notifying the parent of what happened, what should be the new value, right, and then the parent actually does the modification, right? So let me load that into lab 4, parent state component. So parent state component. So there it is. So the parent is rendering the counter, right? The parent is rendering the counter of 1, 2, 3. There it is. And the child is also rendering the same counter, 1, 2, 3, right? So they're both sharing the value and they are in sync, right? They both are saying, okay, well, the value is 1, 2, 3. The parent says it's 1, 2, 3. It's passing it to me, so obviously it's 1, 2, 3. So we are sharing the value, but the modification is happening at the child. It is the child who tells the parent, hey, I want to decrement or increment, right? By calling the functions that the parent gave it, so that the parent actually can implement that that behavior of modifying the value. So this is a very common strategy, right, to share data across multiple components and also share the event handlers, right, that are ultimately responsible for modifying these state variables. Okay? And we'll see how this is useful, in a broader sense when we get to refactor the dashboard and the course and the modules, right? We want to modify them and they need to talk to one another. They need to be able to share the data amongst each other. Okay. All right, so let's talk about application state, right? Now, by application state is, I want to make the distinction that up to this point, we've been talking about the component state, right? So this is, we've been talking about components that maintain their own state variables, right? Using hooks like useState, right? And for the most part, right, they are responsible for maintaining, the values of their own state variables, right? And mostly stay within their context. They're confined, right? Either to that particular component or that particular string. Usually they're not meant to have any effect outside the component or outside that screen, right? It only has meaning inside of that small scope. Now, by application state, I mean data that might be relevant, across multiple components, right? That it has more of a global reach, right? Data that might be maintained at the application level, that has a much broader and wider scope, right, than a small little variable inside of a particular component, right? Now we could use the strategies and the technique that we have so far, the use state. The use state would work fine. I mean, you would have to declare that state way up at the root of the component, and then pass it down through attributes down to each one of the components. So that's a very terrible implementation. So a much better implementation is to separate, right, and have the state live outside of a component, kind of like in a global place, right? And then somehow make that available to everyone who wants to pull that value that is application wide, right? And to do that, we're going to use a technology called Redux, right? Redux is a library that allows us to maintain state, right, outside the components, right? And in a global sense, right, at the application level. So let's create a directory where we can play around with several Redux examples. Right, so let's create under here Redux examples. And let's copy that, right? And then import that into our lab here. Let's see. Redux examples. There we go. There we go. Redux examples. Okay. All right. Now we don't have Redux installed, so we'll need to install it. So let's first use npm install Redux save. So from here, from the command line, we're going to stop the Node.js server. And I'm going to do an npm install Redux. Okay. I'm also going to install a few things. Now, Redux by itself, that's the core library, which it can be used in many different stacks, right? So it can be used in in the on the server side. It can be used here on the front end. It could be used either in other front end libraries such as Angular or Vue.js or whatever. So it's not specific to render.js, right? It's a library that allows us to maintain state, right, in a consistent way. Now, to be able to use it within Redux, within React, right, we need to install an additional library, the React Redux library. So this is a kind of like a glue between these two libraries, between the React library and the Redux library, so that they can talk to one another. And finally, the library, the Redux library, is a little bit opinionated, right? It's a little hard to use. So there's a toolkit, there's a Redux.js toolkit that simplifies a lot the use of this library. So I'm going to install that as well. So yeah, so this allows us to do a lot of boilerplate stuff that you would have to write yourself. This would write it for you, right? So maybe basically you can do more with less. Okay. So let me show you an example of a Redux, a trivial Redux example, right? So let's create a hello world here, right? So let's create here a hello Redux component. So in here, under here, we say hello Redux, and in index.tsx, we have a hello world, right? Let's do npm start. Okay. All right. And so let's bring this in. Let's bring this into the Redux example. So hello Redux. So here, hello Redux. Perfect, right? And it's just saying hello, right? There's a hard-coded header that says hello Redux. And then this variable, message or constant, it says hello world. Okay. And so say I want to be able to change this. If I want to be able to change this, then I would have to do what? I would need to put this in a square bracket, right? I would need to put this in a useState like that, right? Oops, useState like that, and so on and so forth, right? And then create a set message, like just like we've done so far, right? If I want to be able to modify this, and I would have to put this in an input field, blah blah blah. Okay. But I don't want to do that, right? Because again, this is local state. It's hard for me to use this message anywhere else, but only in this component. Although I could have other subcomponents that I can pass it to them, but I don't want to do that, right? Instead, I would want this to be somewhat kind of like a global variable, right? That I could avoid all the bad things about global variables, but still be able to access it safely. And so how do we do that? How do I declare message in a global space and then be able to retrieve it from here, okay? All right, so to do that, we are going to create a someone who needs to hold this value. So somebody needs to hold the value globally, all right? So to do that, we're going to create a separate file. We're going to call the reducer, right? The reducer file. So the reducer file is going to be responsible for holding the data, right? Because again, the whole point is that I don't want the data to live here. I want it to live in a global place. So outside of this component, well, outside of all components, I want it to be outside of all components. I want to be able to access it and also modify it, right? And so here's my hello reducer. Let's copy the content in there. There we go. And so we what we do is that we declare a data structure that is going to hold the data, right? So our data is that we want some variable, right, message to have the value of hello world, right? So the way we're going to do that is that we're going to create a new object that is going to hold all the data points that we want to make available globally, right? Or at least to that one component. Okay. In our case, it's just message and then the value hello, right? And okay, so that's it, right? We declare that, and then what we do is that we create a slice. Okay, so what do we mean by slice? So because this is a global solution, right? That this state this value here, right? Yes, I'm using it in a trivial example, deliberately in a trivial example. But usually it's if you're going to use it for such a trivial example, then this solution is an overkill, right? You would never use Redux for something so trivial as this. Um, Redux is more for larger applications where you have multiple screens, and perhaps each screen has a set of state variables. So there might be a screen that does the shopping cart, right? So there would be the shopping cart would have an array, it would have all sorts of quantities and products and stuff like that, right? And it would have its own slice of data sets. Okay. Then you would have maybe a checkout screen, right? And the checkout screen would have again its own set of state variables that change over time. You might have a product screen that has its own set of data sets that you want to display in the product screen, right? Uh, so so one, no, and each one of them would have its own set of setters and modifiers and mutators and state variables. Okay, and so each one in this new implementation, each one would have its own small slice of a big pie of data. Okay, collectively, we would take all these various data slices, right, and together they would be the overall application state. Okay, and so this is an example of a trivial slice, right? That it maybe is way too trivial to make it to even be relevant, right? But anyway, we're starting small, right? And we're going to grow into more relevant examples. So we have the initial state. Here's a slice that right now is only capturing the value of this hello world message, right? We give it a name to the slice. We give the data that the slice is maintaining, and we want to make available globally. And at some point in here, the reducers are going to hold the mutator functions, the functions that we would use to be able to manipulate the value of message, right? Which we don't have any right now. We don't want to modify the value, but this is where they would go. Okay, so these are the mutators, right? These are the data. Okay, all right. So once we have that, we are going to now bring together all the slices. We're going to bring all these slices into one store. The store is kind of like a big bucket, right? It's the pie, right? It's the pie that is grabbing all the slices, right, and putting them all together into one big pie, right? And this setup only needs to be done once. You don't need to set it up again. But let's declare it here. Actually, I think I would prefer it to be just store.tsx. Okay, so store. Oops. So in a separate file, store.tsx, we are going to collect, all the various slices or reducers into one single store, right? And so we're going to import. Here we are. We're importing the hello reducer that has the data, right, and has the functions. And then we are going to configure a store that collects all those into one big, all those slices into one big pie, right? Right now we only have one reducer. So this would be the collection of all the reducers, but we only have one right now. As we progress through the lecture and next module, right, we are going to do comma next reducer, comma next reducer, and so on and so forth. Right now we only have one. Okay, so this is the collection of all the reducers into one big reducer, right? And finally, we're going to take that store and we're going to provide the store to the entire set of labs so that all the data that is in the store is going to be available to all the labs, right? Not only to my lab 4, right, but also across lab 1, lab 2. Everybody's going to be able to see this, right? And so let's bring in the store, right, into the labs. So let's go to labs. There we go, here, right? And we're going to bring in the store. Where is the store? Oh, here, no. We want it up here in the labs. There we go. Import, blah, 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 blah. Nope. Oops. Oh, maybe I put it in the wrong place. And labs index.tsx is bringing in the store. Actually, let me put it back where it went, where it was. Store, lab 4. Do I want it in here? Well, in later labs, I'm going to use the store. Probably not. I'm just going to use it here in lab 4. So that's fine. That's fine where it is. I just need to, when in lab here, when I import it, I need to say where it is. So it's under lab 4 store. I think that's where it is. Yeah, there it is. Okay, so we import the store, right? We also in the React Redux. This is the library that we installed, right? That is the glue between the Redux, the low-level Redux library, and React. And in there we have the provider, and the provider is, like the name suggests, right? It's going to make available the store, the whole pie of data is going to make it available to the whole application. So we're going to make this global. We say provider, store, right? And notice that we are surrounding, right, the whole application with the store. Okay. Now the store is encompassing all the labs, right? All the labs are going to be able to access whatever data is in the store, right? And what's in the store? The hello reducer. And what's in the reducer? Oops. We have the message. We're going to be able to extract this message, right, from that reducer. Okay, so anybody, lab 1, lab 2, lab 3, and in particular lab 4, right? So in lab 4, any component, right, anywhere, right, click events, counter, all of them are now able to retrieve the message, right? But in particular, we want to go into the hello Redux, and now, right, remove this message like that, right, and bring in and be able to select the message from that reducer. Let's do that. Okay. So what we're going to do is that we're going to import here. Well, we don't need to use dispatch. Here we're going to, from the React Redux, we're going to bring in the selector. And the selector is going to be able to, like the name says, select the message from that reducer that we put in there, that data structure. Okay. And there it is. Here it is. Let's take a look at it. It's saying, and there it is. There's my message. Hello world. Right? I am selecting from the store, or here I called it state, has a hello reducer, and hello reducer, this returns, right? This returns this object right here, which has a property message. And so So the object, from that object, I am destructing and extracting this message, right? So it gets the value of hello world, right? And then it renders right there. So here, if I make any changes to this, hello world 123, save, there it is. See that? Whatever value is now in the reducer, right, is now available to the my hello Redux, right? Actually, it's available anywhere, right? So if I do the same thing here, if I grab this and I take it, say, to any other component, say the array state variables, this one over here, the array state variables, I can do the same thing. I can do a select like that, right? I'll need to import this. Let's import that. And I can put in here, H3, the message. Let's say the message, right? So if I go down here, right there, and I do a message like that, and save, there it is. See that? Hello world. Right? So it's available in any component, by being able to just select it, like I would if this were a global variable. Even if I go to, say, lab one, say here in the headings tag, if I go to labs, I go to lab one, right, and I have all these exercises, right, I can use the selector, there it is, right, I can import it, right, and so now from lab one, I have the HTML examples, I can put in here the message, message, save that, there it is, hello world 123, you see that? Right. So basically what we've done is that the strategy consists of separating two competing or two complementary aspects of user interface development. Right. One of the aspects is the maintenance of the data. Right. So somewhere outside of the component, we are maintaining the data, right, in the reducers. So in the hello reducers. So here we are maintaining the data and only the data. Notice that it's not. It does not have it. It's not going to contain any rendering, components or HTML or DOM or anything like that. Notice that the extension is that TS. See that? So it's only data and it's only event handlers, right, that manipulate that data. We don't do that yet, but it's going to be here in the reducer. So whereas the components, right? The component is not responsible for maintaining any data whatsoever. It's only responsible for retrieving the data and then rendering it. Okay, so it's basically separating those two concerns. One is how to maintain the data, how to manipulate it, how to update it. Okay, and the other concern is how to render it. So that the mutator can deal with all the idiosyncrasies and all the concerns of how to maintain the data, manipulate it correctly, right? And the component can deal with the being the best implementation of rendering this data somehow. Okay, and so this is a very common strategy in user interface development, right, where we separate these two concerns, right? If you might have heard of the model view controller architectural design pattern, right, where we have the view is only responsible for rendering the content for the user interface, for the user, right? It doesn't know where the data came from. It doesn't know how to edit it, right? How to manipulate it. It only is responsible for rendering. The data comes to it, right, and then it just renders it. And if somebody clicks on something in the user interface, it notifies a controller. The controller is responsible for taking those events, right, and causing the model. The model is the one responsible for holding the data, manipulating the data, having the data structures, right? So this separation of concerns is a very common strategy of breaking up, these concerns, right? And so in this case, this would play, our component here would play the role of the view, whereas the reducer would play the role of the controller, right? And now for a bit, the reducers are also going to play the role of the model, right? But eventually, the model is going to go to the server, right, in the database when we see that in an upcoming set of modules. Okay. So anyway, so that's the introduction to Redux. Let's take a quick break, right, and then we'll go into office hours.